This video is about solving trigonometric equations. It's found in section 6.5, and this video is part 3. In this video, we're going to focus on equations that are in quadratic form. They're not exactly quadratic equations because they have trig functions in them, but they will work like quadratic equations that we've seen before. And I'm going to show you 3 types. Okay, here's the first type. And we will do the solutions that are in the interval from 0 to 2 pi. Okay, so let's say you have 4 cosine squared theta minus 3 is equal to 0. The first type is where you only have one trig function. In this case, it's cosine, and it's squared. So in this kind of a situation, you can use square roots to solve the problem. All right, what you'll need to do is isolate the trig function. First, it's square. So we're going to isolate the cosine of theta squared. So we will add 3 to both sides. And that will give us 4 times cosine squared theta being equal to 3. And then we'll divide both sides by 4. And that'll give us the cosine of theta squared is equal to 3/4. All right, now remember, this means the cosine of theta squared. That's what it is. Okay, so what we're going to do is take the square root. So the cosine of theta itself then is going to be equal to the positive or the negative square root of 3/4. All right, that's the very tricky part, trying to remember that you need a plus or a minus in there. Okay, now this does simplify to plus or minus square root of 3 over 2. Okay, so we've got to find places where cosine is equal to the positive square root of 3 over 2 as well as the negative square root of 3 over 2. So if we think about the unit circle, all right, cosine x coordinates. Okay, we've got at pi over 6. The cosine is positive square root of 3 over 2. Also directly below it, 11 pi over 6, it's equal to positive square root of 3 over 2. And then if we go over to 5 pi over 6, cosine is negative root 3 over 2, and 7 pi over 6. So we will have 4 solutions for this. All right, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, so this problem, we had the trig function squared. All right, and the next kind of problem, here's the example, 2 times the sine of theta squared minus the sine of theta equals 0. Okay, you can see we have 2 different terms that have trig functions. All right, so this one is a little bit more complicated than the other one. What technique we'll be able to use in this one is that there is a greatest common factor. So if you look at both these terms, they both have the sine of theta in common. So we will factor out a sine of theta, and then this will be equal to 2 times the sine of theta minus 1 being equal to 0. And then we're going to use our zero product property, okay? The one in general that if 2 numbers like a times b, if 2 numbers have a product equal to 0, then at least one of the numbers individually has to be equal to 0. So we'll just use that for our equation. So one of the factors is the sine of theta. So either the sine of theta itself has to equal 0, or the other factor is 2 times the sine of theta minus 1 equals 0. All right. Okay, so this one we can go ahead and figure out where the sine of theta is equal to 0. All right, sine of 0 at 0 and at pi. This one we have to isolate the sine of theta. So we would add 1 to both sides and then divide by 2. So we'll be finding where the sine of theta is equal to 1/2. Okay, so if we think about on the unit circle there, sine is 1/2 at pi over 6 and also at 5 pi over 6. There are 4 solutions to this problem. Theta could be 0, pi over 6, 5 pi over 6, or pi. Okay.